Hello friends, welcome to Electronic Circuit Hub. So today we are going to understand about the automatic LED light control using LDR. So you might have heard about the LDR. LDR means that light dependent resistance. That means it is kind of sensor which changes the resistance value based on the ambient light falls on it. Let us say if you go and see the data sheet of LDR, you may see that the dark resistance of this LDR is something else, and once the light ambient light falls on it, you will see there is a change in the resistance. So we are going to simulate here using the LDR, what is the change are, how you are controlling the brightness or intensity of your LED display D1 by using, let us say this is our LDR, our R3 is LDR. By using this LDR, what is the change in current? If there is a change in current, you will see there is a change in light 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 intensity. So let us understand first how this LDR works, how this circuit works, and what is the impact on your LED display or your LED light. So let us first understand this circuit. So you can see here this is the 5 volt, and what I'm trying to do here is this is the R1 which is 75 ohm, and this is the LED diode, and this is the transistor. And if you go and look the data sheet of this D1 NSPW500BS, you will see the VF max is 3.4 3.5 volt. So this is the VF max, and if you go and look at the data sheet for current IF max, they have given is 30 milliampere. So in this circuit, what I'm going to do is I have designed this circuit to pass the current around 20 milliampere. That means 5 volt minus, if you go and calculate this, so 5 volt minus, consider the maximum forward voltage of LED, that is 3.5 volt, and if you divide this to 75 ohm resistance, you will get around 20 milliampere. That's okay. So that is how I biased the R1 resistance, okay, in order to limit the current of LED. And if you go further here at this point, this is the NPN transistor then I have used, and this is the PNP transistor I'm using to drive the NPN transistor Q1. And once this transistor Q2 is on or PNP transistor is on, that supplies the current to the base of the Q1. Once the Q1 is on, there will be a current flow in your D1 or LED, and you see your light intensity here. So that is about the PNP transistor and these two resistance. Now let us come back how you are going to bias your PNP transistor, because this is also critical. If your PNP transistor Q2 won't work, that means your Q1 won't work. That means there is no current flow through your LED or D1 diode. Okay, so in place of using the actual LDR, what I have done here is, since LDR is a light dependent resistance, so I took one resistance, I called this as R3, and what I'm gonna do now here is I'm changing the resistance value by using this dot parameter, dot step decade param R. R means I'm putting this, I'm defining these, the value of R here by using this step parameter, and R equals to R, the minimum value of R is 500 ohm, and the maximum value of R is 10 kilo ohm, and I'm sweeping this resistance value with the step of 100. That means 500, 600, 700, 800, 900, 1000, likewise it keep on increasing. Okay, so uh, if you understood correctly the property of LDR, that means it changes the resistance value there is a some resistance when there is a dark condition, there is a no ambient light, and there is a some resistance when there is a light rays falls, ambient light rays falls on it. That is how I model the LDA by using register, and I am using here the changing register. Register value is changing from 500 to 10K with the step of 100. So that is about the R3, and I have connected R4 is 10K. So I'm using 5 volt here to drive the LED, and the LED forward voltage, maximum forward voltage is 3.5, forward current is 30, using NPN transistor BC547 to drive this path. Then again I'm using PNP transistor, and the collector resistance here I'm driving this Q1 transistor by the help of Q2 transistor, and R3 is LDR. I have one model the RT in a such a way that changes the resistance value in order to control the display, control the intensity of your LED light. And this is the R4. So R3 and R4 is the biasing resistance for Q3. So hope you have understood how you're gonna control your LED display with the help of LDR. You can use this LDR sensor. It's very popular sensor if you're talking about the light things. If you're talking about, if you want to change anything based on your ambient light. Okay, now let me run the simulation and let me show you the impact and how this circuit works. Let me show you the different current waveforms which is flowing through the D1 diode. So I'm gonna run the simulation. I'll run the simulation, then I'll go window, then tile window vertically like this. Probably do this for zoom fit. This is again zoom fit, and let me show you one by one. This is your 5 volt, and this is your LDR. If you look at the current is changing here is from few microampere 40, let's say here I see is around 64 microampere to 480 microampere. And let us first analyze here what is the current flowing through your diode. So this is important thing. Okay, so if you look at this point, this here, so let's say when your resistance value is 500 ohm, at this point here, you see at this point your current is 0 milliampere, and for some resistance here your current is 1 milliampere, and here you see 3.8 milliampere, here you see 8.17 milliampere, here you see 14.43 milliampere, here you see 20.3, and the maximum current you see for probably 10K is, if you look at and see here, this is around 21.65 milliampere. So that means you are changing the resistance value here. You are changing the resistance value for LDR starting from 500 to 10K using the step of 10K, and you see there is a change in the LED current or diode D1 current, which you can see here clearly. It is starting from 0 milliampere and it goes up to 21.6 milliampere. So that is how you can see based on your ambient light. If you connected your LDR outside of your home, and you want to control your LED display or LED light somewhere inside your home, this is the most popular method you can do, based since LDR works based on the ambient light condition. If the ambient light is more, you will see less current flowing through the LED, and LED intensity will be very less. And if you see your ambient light is less, you see the more current flowing through the LED, and you see LED intensity is more. That is how you can control your LED display with the help of LDR. So I hope you guys you have understood how you're gonna design the circuit for automatic LED control by using LDR. And if you have any further question, feel free to ask me in comment section. Thanks for watching this video.